Welcome to the heat equation. So we are going to consider a very specific case of heat transfer. Let's consider a metal rod of length L. And we will initially consider the ends to be both held at 0 degrees. So let's suppose both ends are held at 0 degrees. And then we can suppose that the rest of the rod, at least we know the initial temperature, right? So, and suppose the rest of the rod has initial temperature of f of x, where x is the position in centimeters from one end of the rod. Or the displacement distance from one end of the rod. We're going to assume that the rod itself is essentially insulated around the outside. So we'll assume the surface of the rod is insulated. Then the heat will essentially transfer throughout the rod over time. So the model that we are going to work with is we will let u of x comma t be the temperature in the rod at position x and time t. I'm going to update my screen. Trying again. So again, u of xt is the position in the rod, or the temperature in the rod at position x and time t. Then the temperature is modeled by the partial differential equation the partial derivative with respect to t is equal to a squared times the second partial derivative of u with respect to x. So we have the first partial derivative with respect to t of u is equal to a squared times the second partial derivative with respect to x of u. Furthermore, we also have boundary conditions. So our two ends being held at 0 degrees, we have that u of 0 t is equal to 0. And we have that u of L t is equal to 0. Both of these we usually define for after the initial point in time. So sorry, for t greater than 0, not t greater than infinity. So these are both for t greater than 0. Our partial differential equation holds for t greater than 0 and 0 less than x less than L. In addition, we also have an initial condition. So in this case, x can vary, but t is set at 0 for initial condition. This is our initial temperature in the rod at position x. This was equal to f of x. And this is for 0 less than or equal to x less than or equal to L. So we have essentially what is often referred to as an initial boundary problem. We have an initial value problem and a boundary value problem combined, since we do have two different independent variables involved. So we are going to be working with this particular model in the next quite a few videos. So in the next 3 videos, we will derive the solution to this model.